Okay, here's our fourth review, partial review for final, mostly exam one material, as I keep saying, and a little bit extras, but not that much. Don't forget, you have a lot of exam two and exam three material you can go through to prepare for the final lot of videos and a lot of review videos from the past. Okay, so now I need to get this thing to come down, as we've done already a few times now. Let's get this guy to come down. There we go. All right, so now what do we call this? Keep calling this the same thing over and over again. Math 105, partial review for final. And we are up to D. This probably is the last one. We'll see. Okay, so here's problem number one coming up on this video, and it looks like this. It's a little bit on the long side. I needed some fresh paper for this. 3x squared plus, it's not necessarily hard, but it's just long to write down, minus 11 in parentheses. Then comes minus. All this is going to be adding up like terms. There's not going to be anything special about this problem, but we're practicing it anyway. Minus 5x squared plus 2x. It's from the exam one material after all. And then add to that another plus. And this one is minus 7x squared, minus 7x plus 9. And we got to add all this up together. So this is going to be 3x squared plus 7x minus 11 unchanged. This minus will change everything inside the parentheses. Whatever it used to be, it's changed. From it used to be minus, now it's a plus. Used to be a plus, now it's a minus. Used to be a plus, now it's a minus. This won't change. All right, the plus won't change anything. Minus 7x squared minus 7x plus 9. Let's get like terms. 3x squared, 5x squared is 8x squared. 8x squared minus 7x squared is just plain x squared, 1x squared. That's it. 8 minus 7. 7x and a negative 2x is 5x. And 5x and negative 7x is negative 2x, right? It's negative 2x. They can't, actually, this 7x and this negative 7x cancel each other out. What's left standing? The minus 2x. Okay, what about the constants? Negative 11 and negative 1 is negative 12. Negative 12 and 9 is going to be negative 3, and this problem is over. Let me conserve some space in case we need it. And that's it for problem number one. Problem number two on this video. As follows, a short problem. What if you have, and this is an oldie, 27 to a partial a fraction exponent, a fractional exponent, a fractional exponent, 27 to the 2/3. So we said A, two steps. A, first take the bottom, the cube root of 27. First do the cube root of 27, and you get 3. And B, step 2, is take that 3. Where did I get that 3 from? I got it from over here, the interrupt step, and then raise it to the numerator. So first deal with the denominator as a root, and then deal with the numerator as a exponent, a regular exponent. 3 squared is equal to 9, and here is the final answer, right? I don't mean to circle this as the final answer. Here is the final answer right here. Okay, let's cordon this off. Again, conserving of space is what we do here, and just in case we need it. And we go to problem number 3. Okay, this is a little bit more complicated. What if you have, not really, x over x squared minus 5x plus 6, and then add to that, looks pretty not bad so far, plus 1, it's an addition, hold on, x squared minus 5x plus 6. So now you notice that the two denominators are good. We don't have to look for a common denominator. We have a common denominator. That's great. So looks like the answer will be x, just add up the two numerators, x plus 1, over x squared minus 5x plus 6. And it looks like we have the final answer, but there's a deception here. There's a deception. Let's go and factor. Let's factor the denominator over here. Let's factor x squared minus 5x plus 6. Let's factor it and see what happens. Let me move up the paper so we don't lose anything, I hope. Okay, move up the paper, get everything we can get out of it. Let's factor this. On the right-hand side, I scrap paper. Okay, what do we do for that? Put down the 6, and then that's the constant, and then underneath that, put the middle coefficient, -5. We're looking for magic numbers. A times b, the coefficient of x squared is 1, so it's the easy one. A times b is equal to 6, and a plus b is equal to -5. What are our magic numbers? Our magic numbers are positive 6 and positive 6 and I'm sorry. Yes. What am I saying? No, -6 and positive 1. I apologize. -6 and positive 1. Here we go. -6 and positive 1. Actually, there's two possibilities here. Okay. -6 and positive 1. What am I talking about? I'm not sure why I'm getting mixed up over here. It's not -6 and positive 1. It is -3 and -2. -3 and times -2 is positive 6, and -3 plus -2 is -5. I apologize. Those are our magic numbers. Okay, so if those are our magic numbers, oh, I see the problem over here. Fine, so we'll do another one. We'll do another one. This is not the one I wanted to show you. But anyway, in this case, it comes out that the factors are x and -3 and x and -2, and there's nothing special happening over here. We can't cancel out with the x plus 1. I wanted to give you another problem. I apologize. Let's go to 3a. I don't want to ruin this whole video by starting it all over again. So I'm going to 3a, and I'm going to give you a different problem. Here's the problem I want to give you. What if you've got, this is for problem number 40. Here we go. X over x squared plus 7x plus 12. Here's the problem I wanted to give you. I apologize. Plus 3 over x squared plus 7x plus 12. And here again, it looks like it's an easy problem. They're both the same denominator, x plus 3 over x squared plus 7x plus 12. But here's again, we've got to go to scrap paper, right? Let me cordon off these two problems. We got to go to scrap paper, and we got to figure out what is the magic numbers that when you multiply them together, you get 12. A times b is equal to 12, and when you add them together, you get the middle coefficient, which is 7. And the answer to that is 4 and 3. 4 times 3 is 12, and 4 plus 3 is 7. So now, let's see what happens when we break that into two factors. This becomes, the magic numbers are 4 and 3, right? So it's x plus 4 and x plus 3, both positive. Positive 4 and positive 3. Now, here's the special thing that happens that cancels. That's the problem I wanted to show you. So the final answer, here comes the final answer. This turns into a 1, right? It doesn't disappear. It doesn't turn into a 0. It turns into a 1. And all that's left standing on the bottom is x plus 4. And here is x plus 4. And here is the final answer, completely done. Okay, so that's it for this video. This is pretty much completes the jobs of the videos. In case I might add one later on, but for the moment, this is it. We're talking about for the partial review for the final.